Welcome to the Student Sheds Zoom BGCSE Bootcamp. And in this bootcamp, what are we going to do? We're going to simply solve multiple BJC exams. And here's the first exam that we're going to solve. Is the 2014 exam. We're going to solve all the papers for each of the exam. Alright, so without further ado, let's get into it. So the first question, and also this recording will be available for your download, and also these these exams that we have, they're also going to be available for you to use and utilize for practice and review. So here's the first set of questions here. What I've done is I've copied these questions into a notepad so that we can solve together. And the first question is pretty simple. What you will notice if you take multiple exams, they're going to start off very simple, and then they're going to get a little bit harder and challenging as the exam progresses. So it's very, very important that you get as much correct marks at the beginning so that you will leave yourself a little bit of wiggle room for any mistakes later on when the questions get a little tougher. So these questions are pretty straightforward here. You're basically adding. So here we're adding these three different numbers. And the first thing you do is just basically go over the process that you've learned before. So here you start off here at the very end, and you add up 7, 6, and 4, right, which is 17. You carry the 1, you put down your 7, and 5 and 3 is 8, plus another 5 is 13, plus the 1 that you carried, that will give you 14. Then you just carry the 1 again, and then 8 plus 1 is 9, plus the 1 that you carried up here, which is 10. So you carry the 1 over here, you put your 0, and then the last column is 6, 2, and 1, which is 9, and therefore your answer is 9,047. So it's very, very simple, very straightforward. This problem here with subtraction here, the rule, remember, if by any chance the first number here is smaller, then you know you have to borrow, right? So that's what we did over here. So we borrowed from the 3, that makes 2. You borrow a 10, a 1 unit, and you put the 1 next to the 7, which makes it 17. So that's a 10 plus 1, 17. So therefore, once we have the top unit bigger or larger than the bottom unit, then we can subtract. So here we go, 17 minus 8, which is 9. Okay, remember we borrowed 1 from the 3, so therefore you only going to have 2 left. So 2 minus 1, which gives you 1, right? And then then the next digit, we have 9 and 9. 9 minus 9 is 0. So, and then you go here to 4. 4 minus 2 is 2, and that's your answer. So it's very, very straightforward, very simple. Here, multiplication, same thing. You just multiply instead of add and subtract. You multiply and then you carry over. Nothing difficult here. 7 times 8, 56. 7 times 0 is 0. Plus the 5, okay, 5, 6. 7 times 1 gives you 7, and 7 times 5 is 35. Okay, so that's very straightforward. 4 divided into 60, 84. In this case, we start off with 4 divided by 4 into 60. Well, we ask ourselves, okay, this is how you would tackle these types of problems here. See this first digit here. You see if this is smaller than the first digit. If it is, you can actually divide into it, okay, and that'll help you out a lot. So because you might not know what 4 into 60 is up front, or 4 into 608 is, or 4 into 6,084. So you start off with a smaller digit that you can easily figure out. So 4 into 6 goes once. 1 times 4 is 4. 6 minus 4 gives you 2. Then the next thing you do is bring down the 0. Then you have 4 into 20. That gives you 5 times. So 5 times 4 is 20. 20 minus 20 is 0. Okay. and then you have, then you're left with 84. Or you can just say, hey, 4 into 8. 4 into 8 is 2. All right, 2 times 4 is 8. 8 times 0 is 0. Or 4 into 4 goes once. When you get to something like 84, you can probably guess to say that 20 times 40 is 80. So therefore, 21 times 4 is 84. But, it's up to you. But that's how you would do this problem. All right, so let's get to the next problem here. Write down as a fraction 3 days out of the total number of days in January. So the first thing you would do is you would want to count how many days total that we have. Okay, so we have 31 days total. So as a fraction, 3 days out of the total amount of days in January would be 3 over 31. Then you would ask yourselves, can I reduce this any further? Can 3 divided into 31, 3 into 3 into itself is once. Okay, we know that, right? 3 into 3 goes once, but what we don't know is if 3 goes into 31 evenly. Well, we know 3 goes into 30, that's 10 times, but we have 31. So therefore, this cannot be reduced any further. So therefore, we leave as is. Okay. So problem 3, we want to round 62.978 to the nearest whole number. Well, the nearest whole number is 63. And the way you figure that out is if you look at the digit that's after the whole number here, 62, and if it's 5 or above, we round it up 1. If it's 5 or less, if it's less than 5, then we round down and keep as is. So for example, if this was 62.324 or something like that, then you would round that, you would keep that at 62. You must remember this. If it's 5 or more, so 5 or greater, okay, so 5 plus, you round up, you go up. If it's, or should I say, greater than 5. 5 or greater, you round up. If it's less than 5, you keep. Okay, you keep your number. Okay, so that's the rule on here for that type of problem. All right, so I am facing southwest. I turn through an angle of 90 degrees in a clockwise direction. All right, in which direction am I now facing? All right, so if we look at where we're facing, southwest is facing this way here. Okay, so 90 degrees. So this right here makes a 90-degree angle. All right, so that's 90 degrees. So if I turn around and I go clockwise, so I'm going in the direction of the clock, which is that way. So if I go this way up to 90 degrees, where do I stop at? Well, I stop at the northwest. Okay, so this is how you would solve that problem. Let's say if I had something where, okay, I was facing south, okay, and I am now, I turn 180 degrees in the clockwise direction. Where would I be facing? Okay, so in that case, I'm starting here south, which is right here, and I'm going 180 degrees. We know 180 degrees, if going halfway up here is 90, then 100 is another 90 here, and this would be 180 would be another 90. So therefore, the whole flat going in the flat line here will be like 180 degrees. So this right here is 180 degrees. So therefore, if I go here and I go around here like that, that will be north. Okay, so 180 degrees will turn me north. This is how you would solve such a problem. All right, write down the next two terms in the sequence. In this case, we look at the sequence and see what's going on here. We're starting off with 16, and therefore we have 16, 14, 12, 10, and then we can figure out the next two, which is easily because we're going down in terms of 2. So it'll be 8 and 6. So that's pretty straightforward there. All right, so Yeah, this one is pretty straightforward. So 10, 14, 12, 10, subtract 2, 8, subtract 2 from 8, 6. Alright, so next problem. The clock, in this case here, one second, let me move this down. Okay, so the clock shows 6:30 p.m. At what time was it 4 hours and 30 minutes before 6:30? So in this case, what you would do is, first of all, let's tackle the hours and then tackle the minutes. So if it's 6:30 right now, okay, 4 hours before will give me 5:30, 4:30, 3:30, 2:30. And then I have to subtract another 30 minutes from that because it says 4.5 hours. So 2:30 minus 30 minutes will give me 2 p.m. Okay, so this one is pretty straightforward. Again, start off, so the technique would be start off with the hours and then the minutes. And you can go backwards or forwards. So for example, if I said that, okay, I'm starting the clock at 6:30 p.m. Calculate what time it would be 4.5 hours after 6:30 p.m. So in this case, you would go 7, 8, 9, 10, which is the 4 hours, and then 30 minutes would give you 10:30. All right, next problem here. What fraction of the diagram is not shaded? So first of all, we need to calculate how much of the diagram that we have. So here we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 cubes in this diagram. So what's not shaded is these 1, 2, 3, 4, 5, 6, 7. So 7 out of the 10 cubes is not shaded. Okay? Express the shaded part as a decimal. So if you look at the shaded part here, we have 1, 2, 3. We have 3 out of the 10 that's shaded. So therefore, if we divide that and make that into a decimal, we just divide 10 into 3. So you get your 3 and you divide by 10. But we know 10 cannot go into 3. Okay, so the first thing you do is you put a decimal and then you add a 0 here. Okay, so that's the key. All right, when the number is not cannot divide into, we need to add a unit of 10 to it. So we add a 0. Okay, and therefore we can then we have to put a decimal place. So 10 into 30 goes 3 times. All right, and that's it. There's no more calculating to do. So therefore you have 0.3. All right, so that's how you would solve that type of problem. All right, in prime factor form, we have 8 and 12. So here we have 8 in terms of prime factor. So what do we mean by prime factor? Prime factor is basically factors. We're using factors to create the number that only can be numbers that only can be divided by itself or 1. So that's a prime number, right? Multiple of itself or 1. So here we have 8. So 2, 2, 2 gives you 8, right? And these are the prime factorization of 8. 12, well, we get 2 times 2 is 4, 4 times 2, 2 times 2 is 4, which just gives me, and then 4 times what gives you 12? 4 times 3 gives you 12. So the question now asks you, what is the lowest common multiple of 8 and 12? So here we have 2, 3, 2, 2, 2, 2. So therefore, 2 is the lowest common multiple of 8 and 12. So this one is pretty straightforward. Okay, how much greater is 3.9? How much greater than 3.93 is 7.24? So basically, it's saying that how much greater than 3.93 is this number here. Okay, so basically you subtract the 2. So this is how you would solve such a problem. Subtract the 2. So 7.24 minus 3.93. And therefore you start off here. 4 minus 3 gives you 1. We have a 2 minus 9. Well, this is 2 2 is not big enough, so we need to go over here and borrow. So we borrow a 1 from the 7, it makes it 6. You put the 1 here, that makes it 12. So therefore 12 minus 9 gives you 3. And then 6 minus 3 gives you 3. And so this is how you solve that problem. Alright, okay, fill in the square and cube of the given information. So we have the number 3. The number is squared. So anytime we square a number, we multiply the number by itself twice. So 3 times 3 gives you 9. The number is cubed. In this case, we multiply by itself 3 times. So therefore, 3 times 3 is 9. 9 times 3 is 27. Okay, arrange these fractions in order from the least to the greatest. Okay, so in this case, we will look at these numbers here. And there's a couple of ways you can do it. You can convert each of these fractions into a decimal and then see which decimal is closest to 1, is the most closest to 1 as possible. So that's one way to do it, and this is the way I chose to do it. Or you can look at the fractions, but you will have to know fractions pretty well in order to just by eye it. So I wouldn't recommend that method. The method I would recommend is basically just convert each one into a decimal and see which one is closer to 1. So in this case, a half, 1 over 2. 1 over 2 is same thing saying 2 divided by 1, but we know we can't divide 2 into 1, so we have to put a point there, a decimal point, and add a 0. 2 into 10 goes 5. So that one is 0.5. 5 over 6. This one is same thing. 6 cannot go into 5, so it can go into 50. So put a point, a decimal point there, and then 6 into 50 goes 8. 8 times 6 is 48. Bring down to 2. You bring down, and then 6 into 2 goes 3 times, 18. Okay, and so you know what's going to happen is that we're going to always get a 2, a remainder of a 2 here. So 18, so here 18, and I'm going to have another 2, and then another 2, another 2. So this is going to be repeating. 0.3, 3, 3, 3, 3. It's going to never end. All right. So anyway, that's 0.8333. The next one, so 2/3. You quickly do that one. 3 into 2, put a point. 3 into 20 gives 6 times, and therefore 6.6. And again, the same idea. 3 into 20 is always going to give you a 6. And you're going to always have a remainder of 2, so it's going to be 0.66666, repeating itself. All right, and therefore your last one, you do 1 over 12. So we do 12. First of all, we try 12 into 1. We can't go. You do a point. If we put a 0 there, we see that 12 into 10 cannot go. So we put a 0 there now. And then we add another 0. So now 12 into 100. And so this is how you would do this type of problem. So now 12 into 100 gives you 8. All right, so 8 times 12 times 8 gives you 96, right? So we go here, 12 times 8, but we don't need to do the 96. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9, so 96. 96. And then it's going to give you 4. Bring down to 0, 40, 12 into 40. But we could stop right there, because we know that this is a very, very tiny number compared to the others because it has an extra 0. So now you can write down the numbers from the least to the greatest. So the least in this case will be the 1/12 because it has an extra 0 in the front. So that's very tiny. And then we look at which one is not as high, not as closer to 0. So here we have points. We're comparing now 0.66, 0.83, and 0.5. 0.8 is closer to 0, to 1, I mean. So therefore, that's going to be the largest. The second largest is going to be 0.66, and so the third largest is going to be 0.5. So therefore, a half will be next. 0.66 will be next, 2/3, and then 5/6.833 will be next. Okay, so that's the idea. Okay. So here we have a circle has a diameter of 14. Calculate the area of the circle. So in this case, we know the area of a circle is going to be pi times r radius squared. Okay, radius is always going to be the diameter divided by 2. Okay, so half of the radius, half of the diameter will equate to your radius. So radius is going to be d over 2. Okay, so once I have that information, d over 2, 14 over 2 gives me 7, so 7 centimeters. So therefore, area equals to pi, which is 22 over 7, times 7 squared. It's 22 over 7 times 49. So we see that 49 and 22, 49 is on top, 7 is to the bottom here. You can divide these two. Okay, so 7 into 49 gives you 7, and then we have 7 times 22, which is 154. Okay, so let's look at this problem here. Express 1/5 as a percentage. So anytime we're writing a number as a percentage, we have to multiply by 100. Okay, so remember now, a percent means multiply by 100. Okay, so 1/5 as a percentage will give you 1/5 times 100. Okay, so 100 into 5 gives you 20. Okay, so therefore we'll have 20%. All right. Calculate 15% of 200. So in this case here, we have 15% here. So 15% will be, when we rewrite a percentage, it's always over 100. Okay, when we're converting to a percentage, we multiply by 100. So in this case, it will be 15 over 100 of 200. What of means? Of means multiply. So 15 over 100 multiplied by 200. So in this case, we have 15 and 200 on top, 100 to the bottom. So therefore, we can divide these two, because 200 is on top. So 100 into 200 gives you goes twice. So therefore, 2 times 15 is 30. So your answer is 30. All right. Use the symbols greater than, less than, greater than, or equal to make a statement is true. So here you're going to have to know your units. Okay, there's no calculating, no way around it. You're going to have to know what your units are. So we know that millimeters is smaller than centimeters. We know that grams is smaller than a kilogram. Kilo means 1,000. Centi means 100. And I'm assuming here for this question, because we don't have an invalid statement here, this should have been 60, maybe 61 liters, or 6 liters. I should have a big L, not a little L here. It should be a big L, I think. But anyway, I guess, yeah, it all depends on the naming convention. Because the problem is that when you're using typed papers, etc., something like this might come out as 1. So you may be thinking it's a 61, and you may be thinking, oh, wait a minute, this problem is invalid, and that's what they want me to notice. They want me to notice that it's invalid. So in this case, I wouldn't use a lowercase l. I would use a capital case L, so that you could distinctively know that this is not 61. This is 6 liters. Okay, so centimeters is greater than millimeter, kilogram is greater than gram, and then liters is what? Greater than milliliters. So therefore, this one should be greater than. All right, match the word in column 1 with the phrase in column 2 by putting the correct letter in the space provided. So we're looking at for definitions here. So we have here circumference, coefficient, hexagon, reflex, quotient. So you need to know the definition of all these. So let's start off here. Plane figure with 6 sides. That's going to be a hexagon. Hexagon always has 6 sides. Okay. Total distance around a circle. That's always the circumference. The circumference is the distance around a circle. Okay. Angle greater than 180, but less than 360. Okay, and that's going to be a reflex angle. So yeah, angle greater than 180, but less than 360, reflex. The number before a variable is always the coefficient, and when you divide, the results of division is always going to be a quotient. All right. Okay, so next we have here simplify this expression. So this is a simple algebraic expression. So what do you do when you're simplifying algebraic expressions? You add like terms together. So in this case we have a 3x plus a 5x. So 3x plus 5x, that's going to give you 8x. Then we're going to have a 4y, but what do we do with the y? We are minusing 3y. So 4y minus 3y is going to give you 1y. So therefore we have 8x plus 1y. So this problem says calculate the value of c when b equals 10. So in this case what we do is basically we just substitute the value of b into the denominator. So therefore b equals 10. 10 plus 1 is 11. So therefore 88 into 11, that gives you 8 goes 8 times. Alright, so calculate the size of angle y. So in this case, we know that the total amount of angles in the right angle triangle, which is what this is 90. If I'm already given 52, therefore I just subtract the difference to get what the other angle is. So therefore 90 minus 52 gives me 38. And that's how I calculate that one. Calculate the size of the angle W and X. So in this case you weren't given, so if we look at this problem here, which is what, 17, 18, right, okay, here. So you see you're not given what this angle is here or what this angle is here. You're just given what these are. But because these two lines are parallel and this angle intersects these two lines, therefore this angle is equals to this angle. That angle is equal to that angle, and therefore these are corresponding angles also. So 110, 110, and 110 and 110. So these are corresponding angles. Okay. So therefore W is 110 and then X is 110. Okay, so that's very straightforward. Alright, so the next problem, which will be this one here, we're given that James had some money, so now we're gonna figure out how to solve this. So James had X dollars. He lost $5. Okay, write an algebraic expression for the amount that he has lost. Okay, so Y is equals to, how much did he have? He had X dollars. So this would be X. And then how much he lost? 5. So therefore algebraic expression will be Y equals to X minus 5. Okay, he now has $2 left. So therefore when you subtract 5 from X, if he has $2 left, therefore we have 2 is equals to X minus 5. Okay. Question now, solve the equation for X. So in this case, what we want to do is we want to get 5 to the other side of the equation. So we want to isolate our X variable. So in this case, because we have a minus 5 here, okay, so we have a minus 5 here, we add 5 to both sides of the equation. So once we do that, the 5 cancels out, right here. And you're left with x is equals to 5 plus 2. Therefore, x is equals to 7. All right, so this is actually paper 1 that we went through. So now we're going to tackle paper 2 for the second half. All right, so paper 2. So in this case, we want to answer all these questions. Show all work necessary. All right. So list all the numbers that are greater than 3 but less than 8. So remember, we have to think about this. We don't want to list numbers that are equal to 3 but greater than 3. We don't want to list anything that's equal to 8, but you want to list it that's less than 8. So therefore, we have 3 natural numbers, that is, too, because we can put real numbers in there and have some decimal places in there, decimal points, and we don't want that, right? Natural numbers or counting numbers, 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we have 4, 5, 6, and 7 in this case. All right, so we want to write down the following numbers for addition and then add. So here we're going to put 6.83, 41.2, 2.078. So I've listed all of them right here, and we list them in terms of the relevant unit positions. And that's the key, is that you list in terms of relevant unit positions. And in this case here, you would have, this is in the ones unit. Okay, this is the tens unit. This is the ones unit. And then this is the 10th, and then the 100th unit. The 10th here, and then the 100th unit. So you line all of them up, and then you just add. So in this case, you have 8. Nothing else here to add with 8, just 8. You have the 7, and then all right, but looks like you made a mistake here. See if you noticed a mistake. This is not quite right. Let's get rid of this. So we have the 8, all right, that's correct. And now the 7 is not lined up with nothing, but it's lined up with this. So therefore 7 plus 3 gives me 10. Okay, that's going to give me 10. And then we have put the 1, 8, 9, 10, 11. So I put the 1 here, and then I have a 1. Okay, so I think this is what I'm missing. So 6 plus 1, which gives me 7, 8, 9, 10, 1, 0. And then I carried the 1 over here. 4 plus 1 is 5. So it's 550.108 is what your answer should be. All right. Calculate the angle, measure 25 degrees. Calculate the size of the reflex angle. So the reflex angle, again, is that we take, because the total amount of degrees here is 360, if we do 360 minus 25, that will give me what the remaining angle would be. So in this case, it would be 360 minus 25 gives me 335. Okay. Right. So in this problem here, a model train is made using a scale of 1 centimeter to represent 20 meters. Calculate the actual length of the train if the model length is 6.75 centimeters. So we know that 6.5, we know that 20 meters represents 1 centimeter. If I have 6.5 centimeters, so therefore 6.5 times 20 will give me the length. Okay, and then this is what I've calculated here. Okay, all right, and you could double check that to make sure, but that's correct. So this is how you would think about it. All right, so read the problem again. Think about it. If 1 centimeter represents 20 meters, I have 6 plus centimeters. Therefore, 6 times 20 will give me the units in meters. Okay. All right. So a flight leaves at 2:25 p.m. to travel from Presley to Newsley. The flight takes 7 hours and 13 minutes. So what time should it arrive? So therefore you're basically just adding the time. So we have 7 hours plus the 2 p.m. gives you 9 p.m. And then you have 25 plus the 13. That gives you 38 minutes. So therefore 9:38. Okay. That's what you have to watch out for. Very simple, very straightforward. Write your answer in terms of 24-hour clock time. So military time, basically you start off at 1200 and you have 13, 14, 15. 3 p.m. is 15, right? And then 16, 17, 18. And just go all the way around the clock. All right, so we know 9 o'clock, right, will give us 9, 10, 11. This is going to be 1200 here. Should put a 12. Okay. This is the PM actually, the PM time. AM you would go for 01, 02, 03, 04, 05, 06, 07. So this is PM here in terms of military time. All right, and AM would be the exact same time that we're used to. Okay, so 1 p.m., 1 a.m., 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you get to 12, and then 1300, 1400 is the PM. Okay, so here in this case, 21:38, 21 is 9. So 38 doesn't change, so therefore it's going to be 21:38. Okay, because this is 9 p.m. And you could just double check it, you know, even use your fingers if necessary to make sure that you get the right answer, right? So 1300 is 1, 13, 14, 15, 16, 17, 18, 19, 20, 21 is going to be 9. All right, so that's how you do that problem. Okay, what's the mean age of 5 children? The mean age of 5 children is 9. Calculate the total age of the 5 children. So the average is 9. So therefore you have 5. So therefore 9 times 5 gives you 45. And then it tells you that 4 of the children's ages are 10, 8, 9, and 6. All right, calculate the age of the 5th child. So if we know that the total age for everybody is 45, and we're given 4 of the ages, so just subtract 45 from those 4 ages and you would get the age of the 5th child. So this is what you do here. So that's the thinking behind this type of problem. 45 minus 33 gives you 12. Okay, so in this case I want to evaluate 3 1/2 plus 4 3/10. So in this case you have to convert 3 1/2 into a proper fraction first. 4 3/10 into a proper fraction. So once I convert those into a proper fraction, then I can add. So to get these into a proper fraction, we do what? 3 times 2, which is 6, 6 plus 1, which is 7. So therefore I have 7 over 2. To convert this into a proper fraction, you do 4 times 10 plus 3 all over 10. Okay, so 4 times 10, which is 40, plus 3, 43 all over 10. Alright, so therefore I have 7 over 2 plus 43 over 10. Now in this case, when you have two fractions like this, what you want to do is basically we want to find the common denominator, the lowest common denominator between 2 and 10, which is going to be 10. And then you just divide 2 into 10, and then you multiply by the top number here. So your answer that you get here, you multiply by 7. The answer that you get here, you multiply by 43. So 2 into 10 goes 5. 5 times 7 is 35. 10 and 10 goes ones. 1 times 43 is 43. And then you would add the top 2 because we're adding right here. Okay, so you would add these top 2. 35 plus 43 right, which just gives you 78. So therefore the answer is going to be 78 over 10. But 78 over 10 is not in its lowest form. So then you have to reduce that even further. So to reduce this even further, you would divide 78 into 2. You find what number you can divide into both, numerator and denominator, evenly. 78 into 2, 39, and then 10 into 2 gives you 5. So even if it might take a couple seconds to try to figure out what number to use, always start off with 2 when you're trying to reduce. So you start off with 2, then you go to 3. Okay, so because 2 will cover 2, 4, 6, 8, 10. 3 will cover any numbers, all the odd numbers, 3, 6, 9, that kind of thing. So, okay, reflect the shape in the line label. Okay, so here we want to reflect the shape. You're given this F here, and therefore we just reflect it over. So it's 1 unit away from the axis. So first of all, 1 unit away, you draw a line, and it's going to be 1, 2, 3, 4 units up. And then you're going to go 2 units. It's going 2 units across, so therefore you go 2 units across here. So that's how you basically line it up and reflect it. Okay, so it's not hard at all. Very simple. Okay, next problem here. A tank holds 1,600 liters of water. 2/5 of the water was used. So how many liters of water was used? So 2/5 of 1,600. So 2 over 5 times 1,600. So basically, in this case, I guess I didn't show you it, huh? So you can do 5 into 1,600 and then multiply by 2, or you could do 2 times 1,600 and then you could divide that number by 5. All right, so 2 times 1,600 is what? 3,200, and then 3,200 divided by 5 is 640. So I'll let you practice working on that on your own. So you do this one on your own. 2 times 1,600, do a long division, long multiplication, and then you divide that answer. So 3,200. So basically, you practice this. 3,200 divided by 5. All right, and see what you get. All right, write as a ratio of the lowest terms the liters of water used. So we used 640 liters. It holds 1,600. Okay, so we need to write that in terms of a fraction. Okay, as a ratio. So 640 to 1,600 into its lowest term. So what number divide by 640, and then what number divide into 1,600, and then keep on reducing. Remember, for this one, I told you just earlier, always start when you're reducing, always start with 2 and then go to 3 and see how it works. So in this case, I want you to do it. But here, what number? 640 that you can divide into evenly into 640. So 640 divided by 2 is what? 1,600 divided by 2 is what? And you keep on dividing until you get to the lowest form. Okay, which is I already did it for you. But I want you to keep on doing it. Okay, so here in this problem here, you want to evaluate 6 squared plus 3 parentheses 7 minus 2. So where's the order of operations? You always do the parenthesis first. Okay, and then you could do powers and exponents, and then multiplication and division from left to right. Then add and subtract is the last thing you do. So here we have the parentheses, so you do this first. 7 minus 2, which is 5. Okay, evaluate your power, your exponent. 6 squared is 36. 6 times 6 is 36. So we have 36 plus 3 times 5. 3 times 5 is 15. So 36 plus 15 gives you 51. Alright, so bag. So here we have some probability problems. A bag containing 3 red marbles, 4 blue marbles, and 2 black marbles. 1 marble is chosen at random. What is the probability that the marble is a red? So we have a total of 9 marbles. 4 plus 3 is 7, plus 2 is 9. Red is going to be 3 out of 9. So therefore we reduce that to its lowest form. 3 into 3 goes once, 3 into 9 goes 3 times. blue marbles. So we have a total of 4 blue marbles. So therefore, 4 out of 9, and we cannot reduce that. Okay. Black or red marbles. So when you're talking about or in terms of probability, that means addition. Okay, we have to consider both cases. Okay, so therefore, black will give you 2 over 9. Red will give you 3 over 9. So therefore, 2 over 9 plus 3 over 9 gives you 5 over 9. So what's the probability that a marble is gonna be green? Okay, so in this case, it tells us we only have 3 red, 4 blue, 2 black. Okay, there's no green, so the probability is going to be 0. So this is what you have to think sometimes. A trick to this problem would be this. A bag contains a total of 10 marbles. 3 red, 4 blue, and 2 black. So that only accounts for 9 out of the 10. And then if they asked us these questions here, of course we would put 10 to the bottom here for everything that says 9. But when it comes to green, we could assume that green may be the color that's left off or something like that. So this is the type of problem you have to sometimes think about, and you have to read the problems carefully if they try to trick you. Okay. All right. So in this case, it squares 3 inches by 3 inches. Calculate the area of the one tile. So it's going to be 9 inches squared. Right? Area is length times width. Right? A countertop with an area of 1260 square inches is to be covered with these tiles. How many tiles are needed to cover? So therefore, if I know that one tile gives me 9 square inches, I have a total of 1206. So therefore, 1206 divided by 9. It's pretty straightforward. Okay, a church choir has 80 members. There are 10 more females than males. How many choir members are males? So we have a total of 80. So we need to find a way in which we can add 2 numbers together that can give us 80, in which one number has to be 10 more. So that's the thinking behind this. Okay. Yeah, so we have 35 plus 45. All right, so therefore we know that 35 plus 45 gives us 80. And we know that 10 more females than males. So therefore we know that the females are going to be 45, and therefore the males are going to be 35. Okay. What fraction of the choir members is female? So females are going to be 45. 45 over 80. Okay, so therefore you would divide 45. Find a number that you can divide both 45 and 80. In this case, evenly, that is. 2 will not work, 3 will not work, 4 will not work, and then we can see that 5 works. All right. Alright, and your answer, answer in the lowest terms. Okay, I haven't finished the lowest terms here for this one. So if we are 3 into, let's see, well, first of all, is there anything that we can divide into both 9 and 16 to make it its lowest terms? What evenly, basically? What number can we divide into both 9 and 16 evenly? None, I don't think. Right? You can't use 2. All right, because 2 can't go into 9. 3 can go into 9, but 3 can't go into 16. 4 can go into 16, but it can't go into 9. And then 5, of course, can't work. 6. So this is the lowest term right here, 9 over 16. All right. So 14 here, we want to simplify this expression. So in this case, you just multiply, expand the parentheses, 2 times x. So we have 2x minus 10y plus 6. Therefore, so and then after we do this, we need to subtract or combine like terms. So minus 10y plus 6 will give you a minus 4. All right, so we're going in a number line here. Minus 10 plus 6 will give you minus 4. So therefore 2x minus 4y. The length of a triangle are 2x, 3x, and 4x. The perimeter is 81. Calculate the value of x. So we know that the perimeter, we can definitely find what x is. So therefore the perimeter gives you, the perimeter by definition is all the sides added together. So if I add up all the sides, I have 2x plus 4x plus 3x, right? So that's going to give you 9x. So 9x is equals to 81, which is the perimeter. So therefore, if I want to solve for x, I do 81 divided by 9. So I divide both sides by 9. Therefore, divide this by 9, and then divide that by 9. So therefore, 9 into 9 cancels out, so you just have x. 81 into 9 gives you 9. Calculate the value of the triangle, okay, value of angle B. So in this case here, it's a two-part question. Basically, we need to figure out what A is first before we can figure out what B is. Oh, yeah, calculate angle A and B. So therefore, A, in this case, we have 180 degrees in a straight line. I'm given 115 already, so therefore the A should be 180 minus 115, which is 65. Then in this case here, I have 4 angles inside a quadrilateral. 4 angles always add up to 360 degrees. So if I have 3 of those angles, I just subtract 360 degrees to get the 4th. Okay. All right. So in this case, we should have, should have done it the other way. Yeah, B is equals to, A is equals to. So in this case, you add up all these 3 here, you get 110. No, you don't get 110. What am I doing here? Ah, right here. So we have B is equals to 360 minus 110 minus 105 minus 65. All right, and therefore you get 80. Okay, shade the region indicated below each Venn diagram. All right, so A union B. So A, all of A and all of B. So you just shade both A and B. Okay. X prime. So that means I'm shading everything outside of X. And I should have shaded it out here too. Okay. All right, so this is the outside. So all of that gets shaded. You cannot shade in here, right? Because although it's part of Y, but it's also part of X. All right, so X prime is everything out of X. Okay. The Venn diagram represents 30 students of grade 9 who study Spanish and French. So let's look at it. So 10. So we get 12. 10, 20, 22. So you have 25 students that study both Spanish and French. Okay, so 10 Spanish only, 12 French only, and then 3 goes both. But there's 30 students in grade 9. So therefore, the other students who doesn't study Spanish or French has to be this X left over. So therefore, 30 minus 25, which is 5. So therefore, your X is equals to 5. So how many students study both Spanish and French? 3. Okay. How many students study Spanish? So we're gonna have 10 plus 3 because although they speak the 3 speak Spanish and French, they still speak Spanish. So the question didn't say Spanish only. See, right? All right. So they do speak Spanish. So it should be 13. Again, it could be ambiguous, this type of question, but the way I see it is how many students study Spanish. It will be 10 and 3 because they do speak Spanish. They do study Spanish, although they study Spanish, French also. Okay. So 17, speedboat left Islander at noon, headed for Cape Isle for distance of 120 kilometers. The boat takes 1 hour and 20 minutes. Calculate the average speed of the boat. So speed is basically distance over time. So what is your distance in terms of kilometers? 120. Okay. And what is your time? Your time is going to be 1.33 hours. Okay, because we have an hour and 20 minutes. How long is, we need to convert the time into the same units. Okay, so either got to be in minutes or either got to be in hours. So in this case, I think I converted it into hours, right? So therefore, we have an hour and 20 minutes. 20 minutes is what fraction of an hour? We know that there's 60 minutes in an hour. Okay, so therefore 20 minutes is going to be 20 over 60, 0.3333. And therefore I add my 1 hour, so I get 1 hour, 1.3333 for my time. And so I just divide 120 divided by 1.333. And I get 90.2. Okay, so that's how you would solve that problem. 18. Patsy bought 6 dresses, costing a total of $300 for a shop. She sold each dress for $61. Total amount of money she made from the sale of all the dresses. So you're going to have 6 dresses times 61, basically. And so 6 times 61 is 366. Total profit, well, the cost of 300. She made 366, so the profit was $66. 366 minus 300, $66. All right, below is a sketch of isosceles triangle. Using a ruler and pencil and a pair of compasses, construct the triangle using the same measurements. Okay, you're going to have to just manually do this problem on the paper. Because I can't use a ruler and pencil for you. So in this case, you just take your ruler and just measure out 5 centimeters, measure out everything, and just put it on the diagram. Shouldn't be hard at all. Okay, the diagram shows a garden with a pond surrounded by grass. Calculate the length of fencing you need to go completely around the pond. So this is the pond. This is a rectangle, so you know that these two sides are equal and these two sides are equal. So if you go around and to figure out how many fencing needed, 6 plus 3 plus 6 plus 3, just add all of them together. All right, so that'll give you 18. The area of the pond. Area is the length times width. So 6 times 3 gives you 18, so it's 18 meters squared. The area of the grassy region. The grassy region, when you go up here, this is the grassy region here. So therefore, we know that this is a rectangle also. So 18, 12, 18, 12. So these two are equal, and these two are equal, 18 and 18. So area, length times width, 18 times 12. So 18 times 12 is 260. All right, so the table shows the number of Gmalls sold by school lunch vendor in 1 week. Draw a bar diagram of information using the days on the horizontal axis. Horizontal is days, and then the number of Gmalls over here is on the y-axis. So therefore, we want a bar diagram, so the whole unit here has to represent a day. So this is going to be Monday, Tuesday, Wednesday, Thursday, Friday. And you just draw a box covering how many malts we have. For the y-axis, you just go in units, even units. I use 5, so 5, 10, 15, 20, 25. And then I just draw up to 23 for Monday, draw up to 25 for Tuesday, draw up to 5. Okay, and so this is the method that you use to solve this problem. How many Gmalls in total was sold for the week? So you just basically add everything up for the whole week. Just add everything up to get 77. All right, and I think this is the last problem. Calculate the costs of each item and the total bill for the following items. So here we have 9 oranges at 3 for 99 cents. Okay, so the cost, if you're going to do 3 for 99 cents and we got 9 of them, then we're going to have 99 times 3. All right. Okay, so that's 297. 3.5 pounds of grapes at $4 per pound. So we're going to have 4 times 3.5 in this case. All right, so 4 times 3.5 gives you 14. 1 bag of onions, $2.99 each, so therefore that's going to be $2.99. 6 cans of cream at $1.09 each, so 6 times $1.09. Okay, it's going to be $6.54. Then you just add the total up, which is going to be $26.5. So we have someone who paid $50. $50 minus 23.5. I mean, $50 minus 26.5. So the change is going to be 23.5. All right. So that's actually a fully solved BJC SE exam, paper test 1, test 2. Next session, we're going to solve another exam.